This week, students are preparing for their Unit 4 test, and a big part of what we're going to do is we're going to review some of the strategies that we've talked about in the last few weeks. If you remember back to Module 1, we worked on addition, Module 2 was subtraction, and then Module 3 was measurement. So you'll see all of those things come up in our homework. Looking at number 1, they're asking us to solve using the standard algorithm method. And the standard algorithm is the one that most of you are probably familiar with, where we just start looking at the ones, we add up our ones, move to the tens, move to the hundreds. So if we look at our example, we're going to notice that they did 9 plus 4. And if we see that right here, 9 plus 4 equals 13. They wrote down the 3, and they carried that 10 over to the tens column. So now we have 10 plus 50 plus 40. And we are trying to get students to say that versus just saying 1, 5, and 4, because then we understand that when we add it together, it equals 100. So we're putting the 0, and then the 100 goes, the 1 goes in the hundreds place. And then we have 100 plus 400 plus 100 to equal 600. So I'll just do one more just so that you kind of get the idea, and then we'll move on. So 7 plus 4 is 11, so I'm going to put my 1 and then carry my 10. So 10 plus 80 plus 10 is 100. I'm going to put my 0 and carry my 100 over. 100 plus 300 plus 400, 801. Looking at number 2 for subtraction, standard algorithm is very similar to what we did in addition. The big thing to note, and I always tell this to kids, you have to have a big number on top. If you don't, then you need to borrow. So if we look at our example, you'll see that we had a 3 minus 7. Well, our big number is not on top, so I need to go ahead and borrow. One thing that can sometimes help kids is if you think of those base 10 blocks again. These mats represent hundreds. So if I'm drawing 833, strips represent 30, and the little dots represent units. So 833 would look like this. It says I want to take away 7 units. Well, I don't have 7 dots, so then I need to go ahead. I need to get rid of one of those, and a strip is the same as 10 units. So now I have enough. So that's where I got my 13. Now I can take away 7. I'm going to wait to actually do the final answer, so I'm going to look at my tens. I now have 2 strips left, so that's where my 2 gets written on top. But I need to take away 4. Again, I can't do that, so I'm going to get rid of one of my mats. That's how I got that 7 right there. And I need to add 5, 6, 7, 8, 9, 10 strips. So now, if I were to total up all of my strips, you can see I have the 2 plus the 10 here, which is how they got 12 right on top. Now I have a big number on top for each, and I can subtract. 13 minus 7 is 6, 12 minus 4 is 8, 7 minus 5 is 2. Let's just do one together. 5 minus 8 isn't going to work, so I'm going to need to borrow a strip or a tens, and then that becomes my 15. So 15 minus 8 is 7. 3 strips minus 4, I can't do that either, so I need to take one of my mats, and then I'm going to turn that into a 13, moving 10 of those strips over. 13 minus 4 is 9, and 6 minus 5, or 600 minus 500, 197. We're basically looking at expanded form for number 3, and what I'm asking students to do is to think about how we add each of these place values together. One strategy I just told to one of my students yesterday that seemed to really help is that if I think of where each of these go, I kind of draw myself little arrows to where I want to put them. So this 5 is going to go in the hundreds, and this 8's going to go in the ones. So if I can do that, then I can kind of visualize, because sometimes we're adding too many zeros in when we're doing expanded form, or we're forgetting to have zeros there. So 20,000 plus 400 plus 50 plus 6. I'm going to take this hundreds, and I'm going to put it right there. I'm going to take this 50, and I'm going to put it right there. I'm going to take this 6, and I'm going to put it right there. So when I get done, my answer is 20,456. And then looking at number 4, it's kind of the reverse. I'm looking at where did I not get some information, and then how can I put it in. So if I look at my example, I see the 40, 1,000 right here, and the 40 goes right here. I see 6,000 right there. I don't see any hundreds. And then I see a 5 in my tens, which is 50, and then my 8 in the ones, which is right there. So it's basically just bringing over numbers. So if you look at A, I see 40,000 right here, which pairs right there. But then I don't see anything for this 1. So this 1 is in the thousands spot. So I need to put 1,000. This 90 goes right here. And then this 2 goes right there. So we know 1,000 is my answer. Again, looking at using the standard algorithm, so we're getting lots of good practice with that, and story problems this time around. So number 5, in December, the cafeteria served 972 breakfast sandwiches. During the first week in January, they served 486. During the second week, they served 538. How many more breakfast sandwiches did they serve? Apparently that's a typo. Did they serve in the first 2 weeks of January than during the whole month of December? So let's first figure out how many sandwiches did they serve in January. So we want to take 486 plus 538. Standard algorithm tells me I'm going to add kind of my stacking method. So 6 plus 8 is 14. 10 plus 80 plus 30 gives me 120. And I have 100 plus 400 plus 500 is 1,024. So now I need to go ahead and do a subtraction to find out the difference. If you notice this word than, that's kind of my key that at some point I'm going to need to subtract. So I have 1,024 minus 972. So 4 minus 2 is 2. I notice that I have a 2, but I can't take away 7, and I can't borrow from my neighbor. So here's where a lot of kids make mistakes. So I'm going to go over and I'm going to borrow from my thousands, and now I'm going to make that the same as 10 in the hundreds. I need to cross out and take one of those tens away, and I need to go ahead and make it over here. So now I can do 12 minus 7 is 5, 9 minus 9 is 0. So how many more breakfast sandwiches? The answer is 52 sandwiches. Please make sure we have that unit on there as well. On test time, if we don't have our unit, we're going to lose points. Number 6, there were 6,742 bags of potatoes stored in the cafeteria. They served 781 of them at lunch and 89 more of them at snacks for students. How many bags of potato chips are left? Same kind of thing that they're probably looking for you to first add and then subtract. So 781 plus 89. Going to go ahead and do our carrying, and we have 870 bags that were used. We started with 6,742 minus 870, and now we can go ahead and solve. 2 minus 0 is 2. 4 minus 7, that isn't going to work for me, so I'm going to need to borrow from my next door neighbor. 14 minus 7 is 7. 6 minus 8 is also not going to work, so I'm going to borrow again from my neighbor. Now I have 16 minus 8 is 8, and my 5 just comes down. How many more bags of potato chips are left? 5,872. You can write bags of potato chips, or if you want to make it easy, just write bags. We're getting really, really good at these two-step problems where we're working on both adding and subtracting. Let's take a look at our problem for number 7. At the basketball game last night, the home team was losing by 48 points at halftime, so fans started to leave. There were 45,862 people at the game when it started, and 17,406 left at halftime. Then another 13,892 people left before the last quarter. How many people were left by the end of the game? So this problem is a little bit different, and I'm going to kind of draw a picture to visualize it. So here's my starting, 45,862. Then I had lots of people leave, right? All these little people, they're leaving the game. So by the time halftime is going on, there are a total of 17,946 that have kind of walked away. They've gone. So we need to figure out how many people were left at halftime. And then we need to figure out, it says, from this pot, 13,892 left after that. So I could be doing a double subtraction, or I could go ahead and add these two together and then subtract them from 45,000. Normally kids seem to think addition's a little easier, so let's do the addition first. So 13,892 plus 17,946. We add them together. We get 31,838 people that at some point left during the game. So now I need to do my subtraction from my beginning number and see what we get. So 2 minus 8 isn't going to work, so I need to borrow from my neighbor. 12 minus 8 is 4. 5 minus 3, or 50 minus 30 is 20. 800 minus 800 is 0. 5,000 minus 1,000 is 4,000. And 40,000 minus 30,000 is 10,000. So how many people were left? 14,024 people.